All right, hello and welcome. Today we're going to be graphing and solving linear inequalities. Today our objectives are to graph inequalities on a number line, as well as solving inequalities using the inverse addition and subtraction rules that are very similar to the inverse rules from solving linear equations. So let's start out here. I want you to circle all the possible values that satisfy each inequality. Okay, so when we look at this, we have x is less than or equal to 4, which means that we can include this number 4. Because it's less than, we have 2 and 3. Again, the reason we can include the 4 is because of this or equals to. 7 is the only one that's not. In this next one, we have x is greater than or equal to 12, which means, again, that we can include the number 12. Reminder, this arrow is seemingly pointing to the smaller number, so 12 is smaller. So 12 must be smaller, x must be bigger, which means that 8 and 10 are not included. Therefore, 12 and 14 are. In this next one, we have x is less than 5. Obviously, 4, 3, and 2 are included. But why isn't 5? Well, because it's missing that little dash down here, so 5 is not included. This last one might have been a little bit tricky because it seems to be backwards. We're used to having the 7 on the left and the x on the right. Well, remember what I said. This seems to be pointing to the smaller. So x is smaller than 7. That means that the 6 and the 4 are the only two that are smaller. And the 11 and 10 are not. If that still is confusing, you're more than welcome to rewrite as x and on the left and a 7 on the right. However, because you switched it, you have to switch the inequality. Was greater than, now it's less than. So x is less than 7, which is obviously, again, 6 and 4. So how do I graph an inequality on a number line? Well, just remember that an inequality includes many solutions. So we want a graph that represents all of these solutions to the inequality. So let's start off with an example. Graph x is less than 8. Well, let's think. What numbers are less than 8? 7, 6, 5, 4, 3, 2, 1, 0, and all the negatives. So first let's do this. Draw a number line. Now 8 doesn't have to be in the center, but at least we have to include some 8 and some numbers on the left and some numbers on the right. And we're going to draw an open circle. The reason is because anytime we have a less than or greater than symbol, we use an open circle because that number is not included. For example, if I were to give you a list of numbers, I would not circle 8 in this inequality because it's less than 8, not equals to. Lastly, we want to draw an arrow that represents all the solutions, and it's going to go to the left. The reason we go to the left is because these are all the numbers less than our original number. Our next example, we have x is greater than or equal to 11. So again, we start by drawing a number line, including 11, and we're going to draw a solid closed circle. Why? Because this is x is greater than or equals to 11, and all greater than or equal to or less than or equal to inequalities use a closed circle. But we're going to draw an arrow to the right. The reason is because all the numbers that are greater than 11 are numbers like 12, 13, 14, 15, and so on and so forth. So in this example, we have x is less than 3. Again, start with drawing a number line. And we're going to use an open circle. Why? That's right, because it's a less than symbol. But we're going to draw an arrow to the left. Okay? We're going to draw an arrow to the left. Why? Well, because it is a less than symbol, and those numbers 2, 1, 0 are all less than 3. But here's another way you can think of it. That less than symbol kind of looks like an arrow, and it seems to be pointing in the left direction. If you're like me and sometimes mix up your left and your right, just know that it's pointing in the direction you want to. In this next example, we have y is greater than or equal to negative 5. Again, draw a number line. I often, when I have a negative number, like to include the number 0 in there to kind of give me some perspective of where's the negative, where are the positives, and where's 0. So again, the two things you want to look for is open and closed circle and if it is a left or right arrow. Well, first off, closed circle. Why? Because it's a less than or equal to or greater than or equal to. So we're going to use a closed dot. Next, we're going to draw an arrow to the right. Why? Well, because a greater than symbol looks like an arrow pointing to the right. Plus, all the numbers greater than -5 would be all the positives, and -4, -3, -2, -1. So try this. Choose the correct graph that best describes the inequality. Now, let me ask another question. Why would I exclude A and D? Well, that's because they're both using a full closed circle. We have a greater than symbol, which is not a closed circle, so it can either be B or C. Because it is a greater than, we're going to notice that it is pointing to the right, and so our answer is B. In this next, I flipped it around. Now I've given you the graph. Tell me which inequality it is. Why is it definitely not A or D? Well, the reason it's not A or D is because they both use the less than or greater than, not or equals to. This is a closed dot, so we can't have a greater than or equal to, or can't have a greater than or less than without the or equals to. Now it's pointing to the left, which means the answer is B. That's the less than or equal to. So quick check, which graph is of 7 is less than M, or equal to M? Okay, well this example is very similar to the one in the beginning. Again, feel free to simply switch this around if this confuses you. Put the M on the left and the 7 on the right, but again, you got to switch the inequality. Notice again that it can't be A, it can't be B because they're using an open circle. C and D are the only two options. Now, if you did switch things around and mess things up, you might have said C. But D is the correct answer because it is a greater than symbol. But also think of it, if you put in 6 into M, is 7 less than 6? No. Is 7 less than 8? Yes. So that's another reason why D could work out. So here's a word problem. Mr. Rubert has $23 to spend at the movies. Using only the facts above, write and graph the inequality that describes how much money Mr. Rubert can spend at the movies. Now think about it. He has $23 to spend. He could spend all that money or less than that money. Now, excluding all the negatives for right now, let's think about what the inequality would be. Well, let's let M be the money that Mr. Rubert has in his wallet. The value of M must be less than or equals to $23. I could spend $23 or I could spend less than that and keep some for myself. So the inequality is M is less than or equal to 23. Noticing that it is an inequality that is or equals to, we use a closed dot. But let's start with drawing our number line. Here it is. With 23 is a closed circle, and we go to the left because those are the amounts of money that I could spend. You try this one. In the state of Pennsylvania, you must be older than 15 years old in order to drive a car. Using only the facts, write and graph the inequality that describes the ages possible to drive in PA. Okay, so I'm going to let Y, you could use any letter, to represent how many years old you could be to drive in PA. Noticing that the value of Y must be greater than 15, because really, can you drive at 15 years old according to this? No, you have to be older, so 16 would be the first year you could drive. So the inequality is Y is greater than 15, but not equals to. So we draw the number line, we do an open circle, and we draw it to the right. The reason again is because it is a greater than symbol, and these are all the ages you could drive. You couldn't drive 14 or 13. Now, of course, probably 100 might be maybe where you stop, but for right now, this is a good enough graph. So here's what we got, a linear inequality. You'll notice how it looks very much like a equation. So it's going to be solved just like an equation. So first what we're going to do is draw the wall. If you remember from the equations from before. And the wall is going to go down here through the inequality. And we're going to do the inverse, which is adding, because it's the inverse of subtraction is addition. Adding 14. So the 14's cancel, and we just add 16 plus 14 to get 30. Now the last thing to do would be one of the last things to do is to graph the solution. So we draw our number line. We put an open circle because it's just less than, not less than or equal to, and we draw an arrow to the left. Lastly, let's check the solution. Now, would we try 30? No, because it's not a closed circle. It's also not a less than or equals to. So instead, using the number line, pick a number. Now, I picked 29, but you could pick any number less than 30. So I chose 29, and sure enough, 29 minus 14 is 15. Is 15 less than 16? Yes, it is. Lastly, to solve another equation, we have y plus 21 is greater than or equal to 7. We draw the wall, and what we're going to do is we're going to subtract 21 from both sides. What this will do again is cancel them out, leaving us with y is greater than or equal to negative 14 after we simplify. When we draw the number line, we circle negative 14, but we fill it in. It's a closed dot because it's greater than or equals to. And then we're going to draw an arrow to the right because it's greater than or equal to. Again, you can pick any number that's to the right. Some people like to choose 0 if they can, but I chose negative 12. Negative 12 plus 21 is 9, and 9 is greater than or equal to 7.